Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Okay, now I'm going to do part 7 now, and I was thinking about doing a video for every single part to go into all the details, but to be perfectly honest, if you've gone through all these other videos and you've got now an understanding on how the regulations is designed and how it's actually meant to be used, you could probably go off on your own at this point quite easily. Let's remember that part 7 is special installations and locations. It's certain unique scenarios where the general fundamental principles and general content of the one regulations is applicable, but maybe these certain scenarios require extra definition, extra levels of control, extra considerations. There are many of them, and it's quite easy when you look at them to understand why they are considered as special locations. But when you actually look in a special location, for example, let's just quickly look at 701. Let's remember that the regulation numbers match the main document with just the section in front. So I have a scope, and then I have assessment of general characteristics. So it's the part 3 content of the book, but it's a bit more of part 3 for just bathrooms. So it's 701.3. And then there's a classification of external influence, and then it's given reference to the fact that with regards to external influences in general, we must consider zonal concepts. We must recognise in bathrooms that there is a presence of water, and electrical equipment in this area needs to be controlled in a zonal manner. This is obviously the same for fountains and for swimming pools, and slightly similar for saunas. So you then have a description of the zones. I can move a slide here actually. Here we go. This is obviously an illustration of the swimming pool, but you get the same idea. So there's a description of the zone. So bear in mind this slide is actually zonal concepts in general for all kind of areas. This isn't the bathrooms that we're looking at here. This is just an illustration of the swimming pool one. When you're looking at the zones though, you have the description of zone 0, so that's inside the tub. And in the case of swimming pools, it's inside the swimming pool, flush with the standing level. Then you have zone 1. Now in a bathroom, this is the finished floor level and a horizontal plane corresponding to the highest fixed shower head or water outlet, or the horizontal plane lying 2.25 metres above the finished floor level, whichever is higher. So I haven't got an illustration of that here. Actually, I can probably use this one. Here you go. So here's a bathroom. Here's zone 0. Now the standing point you go to, because bear in mind it's not necessarily from floor level. A lot of people measure from floor level, but when you're in a bath, you're actually higher up. Yeah. So if you read it, yeah, it's above the finished floor level, whichever is higher. Now the finished floor level, you may think is this, but you need to remember that there is consideration of this change there. But anyway, you measure 2.25 metres up. But if you have a water outlet for a shower, which is higher than that lying, then you push the zone up to there. To be honest, the easiest way to actually understand these is to look in the illustrations. So if you turn to page 244, you've got an illustration of these. Zone 0 is in the tub, and zone 1 is above the tub to a height of 2.25 metres. You'll notice in that illustration there is a little star at the bottom of the tub, and it does say right at the bottom of the page, Zone 1 if the space is accessible without the use of a tool. Okay, so under the bath, so you're in the bath and you can reach under it, that is zone 1 if you do not need to use a tool to access underneath there. If you do need a tool, it's not a zone. Zone 2 is described as the finished floor level and the horizontal plane corresponding to the highest fixed shower head or water outlet or horizontal plane line 2.25 meters above the finished floor level, whichever is higher. Which basically means the same height as Zone 1. And then 0.6 meters from the edge of Zone 1. So what it is, it's the same height as Zone 1, but 60 centimeters away from the bath. So it's reaching out from the bath. Once you identify those zones, and again, there are zones also for swimming pools. Yeah, obviously the zone 0 is flush floor level. Zone 1 in the swimming pool is 2.5 meters from any standing point, including on a diving board, 2 meters away, and then zone 2 is another 1.5 meters away. It's all in the illustrations given. Once you've identified these zones in these types of locations, we can then control the use of electrical equipment, switch gear, control gear, yeah, and the voltages even that we will allow in these areas, which we're going to see in a minute. We've also got then, so that's the 701.3, the assessment general characteristics section of this. We then have the protection for safety section of 701, 701.4. And let's remember the general protective measures. We had ADS, automatic disconnection of supply. We had double or reinforced insulation. We had self and PELV, and we had electrical separation. This was all done in chapter 41 in part 4. So is there any restriction to those protective measures here? What does it say? Well, it says the protective measures of obstacles and placing out of reach shall not be used, and non-conducting and earth-free local bonding shall not be used. That makes sense. If you remember, those types were actually for locations under strict control with skilled or instructed persons. They're not general protective measures. So we're allowed the general protective measures that I've just mentioned. Additional protection, 411.3.3. Additional protection by the use of one or more RCDs having the characteristics specified in 415.1.1 will be provided for all low voltage circuits that serve the location, the bath, so the lighting and the shower and all of that stuff, but also any circuits that pass through zones 1 and zone 2, but don't necessarily serve the location themselves. Let's remember that additional protection was actually a part of protection against electric shock, chapter 41. Hopefully you're starting to see the regulation numbers relate to the main text. Okay, so 701.41, all that content is about automatic disconnection of supply. Okay, well, the protection against electric shock. 701.413 refers to electrical separation. It says it'll only be used for one item of equipment or one single socket outlet. This is your everyday shaver. With self or PELV, it allows self or PELV. It does say though, we will need to achieve basic insulation complying with 416.1 or barriers or enclosures complying with 416.2, which is, we covered that way back in chapter 41. It was saying things like, the insulation should only be removed by destruction or with the use of a cure tool. It would not be easy to remove, and the enclosure itself would be to at least IP2X ingress protection as well. This is not a consideration of the environment at this point. That doesn't refer to the external influences. Those are coming up in a minute. That just refers to the requirement for insulation for self and PELV systems. We then have the supplementary bonding mentioned. So local supplementary bonding according to 415.2 can be established connecting together the terminals of the protective conductor each circuit, supplying class 1 and class 2 equipment to the accessible exchange conductive parts within the room. And it gives you some examples of these connections. It may be installed outside or inside rooms containing a bath or a shower, preferably close to the point of entry of exchanged conductive parts into such rooms. So if you've got a bathroom and right next to it is an airing cupboard or with your immersion cylinder and all the pipe work really that goes into the bathroom is coming from that cupboard, you can do your supplementary bonding in that cupboard. Okay. Where a location containing a bath or shower is in a building with a protective equipotential bonding system in accordance with 411.3.1.2, which is, everyday house kind of scenario. Supplementary protective equipotential bonding may be omitted where all of the following conditions are met. So this is, do we need to do supplementary bonding anymore? If all final circuits of the location comply with the requirements for automatic disconnection according to the regulation 411.3.2. So we did this in chapter 41, TN system, TT system, ZS's. Is automatic disconnection in an earth fault condition achievable? If that's a yes, good. All final circuits of the location have additional protection by means of an RCD in accordance with 415.1.1. Well, we need that because there was a regulation further up the page that told us we needed that. So that's a given. And then the last one here. All extraneous conductive parts of the location are effectively connected to the protective equipotential bonding according to 411.3.1.2. The effectiveness of the connection of the extraneous conductive parts in the location to the main earthing terminal may be assessed, when necessary, by the application of regulation 415.2.2. And without going all the way back to it, I'll just remind you, we've covered this in a few videos now. If we want to determine the effectiveness of earthing and bonding, and if we actually need to have supplementary bonding introduced, what we need to do is carry out a value of resistance measurement between two positions which are simultaneously accessible within the location. So if I was to stand here and I could touch towel rail, which has a let's just pretend that this towel rail has a CPC on a cable going to a flex outlet, and I could simultaneously touch a pipe leading up to the sink, and I'll be like, ooh, do I need to do a supplementary bond between the two? So I'd have to say, right, where's the conductor that will actually, carry an earth fault current? Well, that's in the radiator, because that's the one with the exposed conductive part. This pipe is an extraneous conductive part. We covered this back in chapter 54 with supplementary bonding. Now, what I'd say is, right, how much current will result in disconnection here in an earth fault condition? Well, I can actually discover, the overcurrent protected device, and I can go to the time curve characteristics in Appendix 4. But to be honest, as this will require 30 milliamp RCD protection, we know it's going to trip at 30 milliamp in an earth fault, because that's how it's going to have to be set up. So if I know it'll have to trip at 30 milliamp, which is 0.03 amp, and I know that the value of voltage in a earth fault scenario shall not exceed 50 volts, I'm back to the Ohm's law formula that we have mentioned a few times in this series. So it's just Ohm's law. The 50 volts maximum divided by the amount of current that is required to disconnect the RCD of 30 milliamp, 50 over 0.03, gives us this number of 1667 ohms. And so what you do is you'd stand here and you'd measure between this and between this, and you get a resistance measurement. If it is greater than 1667 ohms, then what you then do is you rearrange this formula in your head. You say, right, and I'll just do it now. Let's say it's not 1667 ohms, but it's instead, let's say it's 2.5 kilo ohm, so 2,500 ohm. I can just throw that into Ohm's law. The current won't change, so I know Ohm's law, VIR. The current won't change to disconnect the device. So I'll just do 2,500, which is the value of resistance I have measured, R, times the current required to disconnect, 0.03, and that tells me the V, which is the value of voltage that will be present in this fault condition, and that's 75. So I can't allow that. This is why I would have to introduce, if I had 2.5 kilo ohm, I'd then have to put in supplementary bonding. If I had anything less than 1667, then I don't have to, because I know that the characteristics of that circuit, it's not going to achieve 50 volts or greater. So it's quite a simple process, just needs to break it down to Ohm's law, really. That goes from 701.4, which is the protection for safety area. We're now going to go to 701.5, which is the selection and erection considerations with the funny external influences that this unique location has. So we have External influences 701.512.2. It's fairly obvious, really. It says in an equipment installed in zone 0, which is obviously going to be immersed, it's IPX7. And in zones 1 and 2, IPX4. It then says, though, further down, that if the equipment is exposed to water jets, such as a power shower or something like that, or there's cleaning going on, then the higher power of the water would need it to go up from IPX4 to IPX5. So that's a simple, and again, this is only for the zones. You don't need, if you had a shaver socket over here, it doesn't have to be an IP4X, IPX6, whatever shaver socket, because it's not in an area that's considered to be exposed to the splashes. We're talking about just this area here. What else do we need to consider? The erection of switchgear, control gear and accessories according to the external influence that is there. Now let's break those three things down. Switchgear is equipment that you switch. That seems simple, doesn't it? Okay. But there is a difference between equipment that you don't need to actually touch to run and equipment that requires you to turn it on. Also, control gear, to vary or to adjust a setting, it requires you to interact with it. If equipment is just current using equipment and you don't have to touch it, we can actually allow a slightly higher value of voltage, for example, to that equipment. But if it requires your interaction in a bath, it's going to be even it's going to be more tightly controlled with these self voltages and other methods. So what are the restrictions? Well, in zone 0, switchgear or accessories shall not be installed. So the only thing left is current using equipment. Yeah, it actually tells you that under current use equipment. In zone 0, current use equipment shall only be installed provided it is allowing the following requirements are met. The equipment complies with relevant standards. It's fixed and permanently connected, so not on a plug and socket or anything. And is supplied by a voltage of self, which is again the safest protective measure that we have. Electrically isolated, extra low voltage. Not very practical when we're doing a lot of work, but in the bathroom it's okay. But they've restricted the voltage even further. So it's self, but to 12 volts. So it's a lowered version of self. With regards to back up to switchgear and control gear, in zone 1, we can have switches, but they must be self to 12 volts. And in zone 2, we can have switchgear incorporating switches and socket outlets will not be installed with the exception of switches and sockets of self circuits with the safety source being outside of the zones, or shaver supply units, which is the exception for zone 2. Current using equipment, zone 1, only the following fixed and permanently connected equipment can be installed. So whirlpool units, electric showers, shower pumps, ventilation equipment, towel rails, water heating appliances and luminaires. You are not allowed to put a shaver unit in zone 1. It must be in zone 2 or beyond. So, and then the last bit there is electric floor heating systems, which I'm not going to go into too much detail. Just have a little read of that. But hopefully we've just gone through 701. You've come to understand that it's all about identifying the characteristics that make it a unique scenario, a unique environment, a unique type of installation. But then recognise that it actually just supports the rest of the book. So there's a 701.3, then there's a 701.4, and a 701.5. As you go through the other sections, you'll see similar things. Swimming pools have a very similar layout. I'm going to very, very briefly go through that. 702. There's a zonal concept under assessment of general characteristics. Yes, because of the presence of the water. You then have the restrictions of these zones. So further down, application of the protective measure against electric shock. 702, because we're in swimming pools here. .4. So if anyone hasn't caught up yet, I'm on page 245, section 702 now. So it says in zone 0 and 1, we are allowed in zone 0 only self of 12 volts. So in zones 0 only self of 12 volts. And then, other than fountains, in zone 1, we can have 25 volts. Then there's restrictions on equipment, being salve or an RCD. Then you have fountains mentioned, which is zone 0 and 1. There is no zone 2 for fountains. And as mentioned there with zone 2 about following protective measures shall be employed. So you have salve in zones 0, 1 and 2 with an RCD. And just an RCD and electrical separation using an isolating transformer. The protective measure of obstacles and placing out of reach is not to be used. The protective measure of earthing and non-conducting location and earth-free bonding is not to be used. Supplementary bonding in this scenario must be installed. Must be installed, and it used to be. That's not here now. There used to be an illustration of this. I think it's in Guys Notes 8 now. But it details all the things that should be connected together. But everything in the environment needs to be supplementary bonded. You have the external influences. Again, the same thing. 702.5.1.512.2. In this case, though, zone 0 is IPX8, not IPX7, due to obviously the submersion, the increased bit of pressure. Zones 1, IPX4, X5 if there's jets, and zone 2, IPX2 for indoor, IPX4 for outdoor, and IPX5 for jets. There's a number of scenarios there. What I'll say now is, from an exam perspective, in your exam, you'll have 10 or 12 or 10 is it or 12 questions on part 7 right towards the end, just before your time runs out. Every question in this area starts with a very big clue. It'll be the word swimming pool or the word sauna or the word caravan, which gives you that huge trigger to go to that very, very, very fine section in the regulations. Okay? So, probably if you have any questions from part 7, the first place to go to, if you're not aware of the actual layout of part 7, is page 239, where you've got your list of special installations and locations. And if you get a question that says like about a medical location, you can then come here and you can see, okay, 710. And then when you're in 710, you've got to think about what the question actually is trying to say. Now, I'm going to go through another video after these, just to show you how I read questions and how I interpret them in the exam. But if you understand the regulations the way we've been talking about it, it shouldn't be too hard. Don't look for the exact wording. Understand the area. And that's what's going to happen in part 7. So it will mention a medical location, but then it then may refer to a socket outlet, which is a selection of equipment. And then in there'll be socket outlets. I think that's actually, there's a common one that goes around right now about the colour of socket outlets in Group 1 medical locations. So it's an identification of colour. Which, again, I mean, if you're wondering what that is, I go to 710, page 275, and I'm thinking, right, this is about the selection of a socket. So I'm not going to be in 710.1, I'm not going to be in 710.3, I'm not going to be in 710.4, I'm going to be in 710.5. It's a selection question. So I go to 710.5, and then I think about the further thing. This is referring to socket outlets. So maybe there's a bit on socket outlets. Now, if I remember the main book, when we were in part 5 and we did common rules, and then we did wiring systems, we did cabling, and then we did all these things, and switch types. But then we did one called other equipment, and that had accessories and socket outlets, and it had rotating machines and things like that. And that was .55. That was chapter 55. So if I look at 710.55, then let's get there. 710.52, 53, 55. So 55, that's other equipment. Oh, okay, and it's actually there. Socket outlets in medical IT systems. Right, and if you go through there should be a colour referenced. And it is actually the bottom line of that page, page 279, the bottom line, it says blue. Okay? Now, you don't have to know that they have to be blue. What you need to know is how, if you're asked a question referring to a socket outlet in a medical location, You need to understand that that's a unique area of the book, and that the selection of a socket outlet refers to part 5 and other equipment. It's nothing to do with protection. It's not protection against electric shock. It's not protection against thermal effects. It's not protection against overcurrent. It's not protection against voltage disturbance. It's a selection scenario. And then if you think about the selection setup, it's an accessory and it's a socket outlet. So it's in the 55 part. This is how you need to get an understanding on the way BS7671 works. And if you can achieve that, instead of hunting down for the answers and stuff, then you're going to be absolutely fine. And you'll actually find the book useful moving on forwards. Okay, just to summarise some of the other the other ways Part 7 works. So we've talked about the zonal concept right now, and then we've looked through 701. We've talked about external influences and things like that. Other things that are highlighted, there's a lot of use of RCDs in Part 7. That's because obviously they provide additional protection most of the time. And they were always, if you actually remember where additional protection was used in Chapter 41, it was where there's carelessness by users or there are certain other external influences. We also used RCDs for protection against fire, so there may be a fire risk. If you go to exhibition shows and stands, which I think is 711, yes. There's a bit in here about that. So yeah, you also had mention of RCDs in 711 for 300 milliamp as a general requirement. So there's a lot of push for RCDs, and there's always a different reasons to why, but quite often this scenario is there's a risk and the solution is RCDs. That happens a lot in BS 7671. There's RCDs for protection against electric shock. There's some more examples there, just as you see them in the book, and you'll notice the sections change, but it's still referring to 41, which is protection against electric shock in there. Same with supplementary bonding. We've just mentioned bathrooms may or may not be needed. In swimming pools they are needed. In agricultural and horticultural they are needed. In medical locations they are needed. So yeah, but again, in all scenarios where they're mentioned as a you must have this, they're going to be the number of the section .415.2. IP ratings are also used throughout Part 7 because, again, the changing external influences, moisture, water, dust, yeah. So there's bathrooms, we had IPX7, IPX4 for Zone 1, Zone 2 IPX4, Zone 3 not applicable, etc. We have a Zone 3, by the way, in sauna heaters. Saunas. There's no Zone 0. In this case, you have Zone 1, which is the area of the heater itself, and Zone 2, which is the ground floor, and Zone 3 is the part above. Just going to check that I've just said that correctly. Yeah, there's an illustration of that on page 255. But again, any question in this area would say a sauna heater or something like that. There is, if you are looking on page 255, there is a little list of things that are required in the zones, zones 1, 2 and 3 above. And do note that zone 3 does detail the limits of the operating of the temperatures of the equipment and the wiring systems, okay? So that's also worth noting. We also have mentions on the erection of a wiring system, whether it be a strict type of wiring system or it could be overhead cabling, buried cabling. Now we mentioned mentioned a few videos ago about burying a cable only. There's no announced depth in BS 7671. It just says sufficient to avoid damage. But if you actually go to agricultural or horticultural, it will give you a depth. If you go to caravan parks, it will give you a height. So there are specified heights and depths through parts of special locations. Some more examples of RCDs for other than for additional protection, which we just touched on really. 500 milliamp is used in construction sites for 32 amps. We have 300 milliamp and 300 milliamp here for fire protection purposes. In agriculture, horticulture, we also have 300 milliamp for. Well, in agriculture, horticulture, we have 300, 100, and 30. So they're very fond of RCDs in agricultural installations. Okay, so you'll notice, the area will still be with regards to protection against electric shock, 41. This one, on the other hand, this must be for protection against thermal effect because it's 42, not 41. And you can see it's actually a fire protection need. So, yeah. So, the regulation number tells you itself. I mean, if you don't even need to see the sentence, you know this is for fire because it's 42, it's not 41. Socket outlet positioning. When you have pitch sockets such as caravan sites or marinas, or the new one, obviously the inland navigational vessels one, pitch sockets, we need to know that there's a requirement of the height, there's a requirement of the quantity of sockets in the pitch. So there must be at least one per pitch, and they'll have individual overcurrent protection, individual RCD protection, and things like that. Just read and familiarise yourself with the layout. Okay, do remember, if you have something regarding, if you have a question, for example, that mentions the height of the outlet of the caravan, that's not the caravan site pitch, that's the caravan's outlet. So refer to, in the question, what it's referring to as to what your location is. Make sure you get your location correct. Okay. I mean, I could really spend hours going through all the finer parts of this, but I do think if you think about it generally, it'll be very easy to navigate, and it'll be very, very easy to understand. Medical locations does kind of do its own thing because of the standards that it's used. It's got its own definitions reference in part 2. It has groups within it, group 0, 1 and 2 locations where applied parts are used or not used. An applied part being obviously a piece of equipment that's going to go into your body. Now, if you imagine being in a hospital and you're stuck there on the bed or whatever, and then there's something shoved up the imagine if the power goes out, and if the loss of power is going to result in danger for yourself, then we would consider this a group 2 location. So failure of the supply can cause danger to life. So maybe this thing's keeping you alive, for example. If it's up there, but the power going off doesn't really create a danger, then it's not a problem, but it is a bit of a nuisance, and that's a group 1. And group 0 is, there's nothing going anywhere in you, and so if there's a loss of supply, unless there's some other reason, we're not really considering it as a substantial danger. And if you remember safety services, which we did at the end of part 5, chapter 56, we talked about classification, and we previewed 710. So have a good look through there. Have a good look at the classification part, which will be 710.56, I'd assume. Trying to think about it. Let's get there. 710.56. So that's going to be the safety services. So 560.4 is the classification part. But familiarise yourself with the layout. There's a lot of content in 710. Some of it is quite specific. There's good mention on IMDs, installation monitoring devices. There's even an illustration of it being used on an IT system. Very good illustration of an IT system with an high impedance on there. We have equipment on the IT system, and this shows you the layout of the monitoring system that will be going around the actual conductors. Let's remind ourselves, the IT system is designed to work so that in the case of the first fault condition, a high impedance in the earth results in an earth fault of very, very low current, resulting in no disconnection. So a single earth fault condition can occur, and then this monitoring system will pick that up and it'll have an alarm. Yeah, so the IT systems are extensively used in these locations. Alright, I'm more than happy to kind of talk more about part 7 if needed, but I think a lot of it is self-evident as you go through. Yeah. Caravans, caravan parks, marinas, extra low voltage installations, electric charging points. The electric charging points content is it's not the same as the IT's code of practice at the moment. So where that's going to go, who knows? It's not quite the same. There's slight differences there. And then 730 is the new one for 18th onshore units, electrical shore connections for inland navigational vessels, which is a long way of saying narrow boats and similar. But yeah, okay. I'm gonna stop this video at this point because I think if you remind yourself of the layout of the regulations, the intent and the the fundamental principles, you can take each one of these special occasions, just read them a couple of times to understand the intent of the book, the intent of the section, and then you can just come back to it later on. Don't forget though, as I said, in your assessment, any questions from this part of the book will have the keyword, be it exhibitions, be it transportable unit, be it a swimming pool, and so don't overdo it with this. If anything, put your time into sitting back and just reminding yourself of how the book's laid out and where that chapter 43 was and what that meant, where the chapter 52 was and what that covered. Try to familiarize yourself with the structure and the layout of the book that way over anything else, because then in the exam or any assessment or any need in the future, you can always just say, okay, that's the wrong protected device, it's not achieving fire protection, okay, device of protection against the thermal effects, and you know exactly where to go then. If you break things down and you talk, you think of it that way. I'll do one more video covering the appendices, which is going to be a very, very brief flick through, and then I'll probably do one last video where I'll talk through questions and I'll just show you how I approach them, and then what I'll probably do is then close it up and hand it over, and I will just then set up some streams to support this in the Facebook group, and then I'll start putting more content in there, some resources and some downloads and some training questions and some answers, and I'll just be there more now that this is online and it's there for you guys to consume at your own pace. But if you feel that this part 7 was a bit rushed, then fine. Let me know if there's anything specific you want me to cover, but otherwise we could have spent 3 or 4 hours in here, and I really don't think that you guys need to, considering how we've already approached the rest of the book. I'm sure we'll be fine. Alright, yeah. See you in the next video.